Just the stuff we want to cover?
Yeah.
Okay, hold on a minute. Let me arrange this on my desktop.
Good.
So arrange those numbers.
Alrighty. Alright, we have 9, 18, 20, 25, 39, and 56.
Okay. Now, what's the median?
On the median is 22.5.
Okay. How would I get the mean?
The mean would be, is it all numbers added up divided by how many there are?
Yep.
The range.
Yep. Is there a mode? Mode means most common.
No, there's no mode.
Right. In other words, if I had two 18s, I would have a mode of 18.
Yeah.
That's what mode means, is most common.
Yeah.
List the four distributions and sketch a dot plot or box plot to represent each distribution. What four distributions are they talking about?
I do not really remember too well.
Well, I don't know either. Hold on. I don't know what four distributions they're talking about. However, we could definitely figure out a box and whiskers plot, right?
Yeah.
You know how to do that, and I know how to do that now.
Yeah.
In other words, I'd have to find my 5 key points. I'd have to find the beginning and end of the first quartile, second quartile, third quartile, and fourth quartile.
All right.
And I can do that. You can do it also. And then your box and whiskers plot is going to go like that, with that being 22.5, this being 13.5,
Yeah.
and this being, Jesus, can they not make anything easy? 95 divided by 2, 47.5.
All right.
No, that's not right.
Okay.
In other words, let's talk about this a little further. What's my first quartile go to?
We did 18 to
18 is the median of the first quartile, is it not? In other words, if my midway point is 22.5, then there's 3 numbers to the left of that. That's the middle of my first quartile.
Yeah.
That's the middle of my third quartile. So my first quartile goes from 9 to 20.
All right.
My second quartile goes from, I don't mean 9 to 20, I mean 9 to 18, right?
Yeah.
My second quartile goes from 18 to 22.5. My third quartile goes from 22.5 to 39. And my fourth quartile goes from 39 to 56.
Yeah.
That's the way you do it, right?
I think so.
So the box and whiskers only goes from the end of the first quartile to the end of the third quartile, with the line being the median of the set of numbers.
Yeah.
So that's the way a box and whiskers plot would look. Now, what must they be talking about with their four distributions? Could they be talking about a normal distribution, a skew distribution, a left leaning, and a right leaning?
Probably. Yeah, probably not as well.
A dot plot or a box plot? Is a box plot the same as a histogram?
Oh, yeah.
Okay. If we're going to draw a histogram of this,
Yeah.
then I've got to find some way to break up these numbers. In other words, I could go from 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. But I got some choices. I know that's 0. Let's break it up into 15s.
Alright.
Just because it looks like that might work a little bit better.
Alright.
How many people are between 0 and 15?
Hold on.
Just one.
Yeah.
Just one. The 9 is the only one.
Yeah.
How many scores are between 15 and 30?
3.
How many scores are between 30 and 45?
1.
And 45 to 60?
1.
So there would be one histogram. That's, what do they call it? Normal, skewed left? How do they define that?
I think it'd be, yes, skewed left.
Yeah, it would definitely be skewed left. In other words, a normal curve has the tallest one in the middle.
Yeah.
Okay. So how else could we do this? Let me do it in a different color this time. Actually, I should have left the black there. But I'm going to do this one in red. And I'm going to go from 0 to 10.
Yeah.
And then from 10 to 20, 20 to 30, 30 to 40, 40 to 50, and 50 to 60.
All right.
How many are in 0 to 10?
0 to 10? There's 1.
Still just one. Hold on, I drew it inaccurately. In other words, it's only going to go like that. Whereas my black went like that. Oops, it's supposed to be black. How come it's not showing up black? It didn't register my black. In other words, that was the one way we drew it. That was the first way. Now, the second way we're going to draw it is by splitting up each bar into 10 units instead of 15. So, how many between 10 and 20?
There's 1.
It's actually 2. 18 and 20 are both between 10 and 20. So that one's going to look like that. How many between 20 and 30?
There's 1.
How many between 30 and 40?
0.
How many between 40 and 50?
1.
How many between 50 and 60?
1.
So there's a histogram if I broke it up into 10s instead of 15s. And that is still skewed to the left.
Yeah.
I'm not sure what the 4 distributions that they're talking about are. So I'm not quite sure how to proceed with this.
Alright. I could probably ask them tomorrow when I come by.
Okay, if you don't have it in a book in front of you somewhere.
I don't.
Okay, well, we're not going to be able to get very far then, because I do not have a book, and I've got like 15 math books, but none of them are going to answer this question for me. Just because I don't generally do statistics. I will be glad when you're completely done with statistics, because I don't have a whole lot of expertise in statistics.
Yeah.
Let's see, that one was nothing to do with 3. 3 is a totally new problem.
Yeah.
If you have a correlation coefficient of 0.912, what does that mean about your data?
I didn't really know how to answer this one.
Okay, well, let me draw a couple of curves.
Alright.
I got that curve. And down here, I got this curve. Now, either of those scatter plots, I can approximate a line. If I approximated a line here, it would probably be that.
Yeah.
If I approximate a line here, it's that. Which one has the higher correlation coefficient, the bottom right or the upper left?
Upper left.
No, the one that's the dots are as close to the line as possible. In other words, this one down here on the bottom right, that's got an R of 1.
Yeah.
Because every dot goes through the line. There's no distance. Whereas up here, if I'm looking at correlation coefficient, what I'm doing is adding up all of these distances. In fact, I'm adding up the square of those distances.
Yeah.
Okay, if I take each distance, square it, add them all up, that's how non-perfect the upper left is. In other words, the straight line does not go through all the dots. It approximates the dots.
Yeah.
Well, the closer the line comes to going through the dots, the closer R gets to 1.
Alright.
Now, this is a pretty high correlation coefficient, number 3. It's 0.912.
Yeah.
That's pretty good. That's not quite the lower right, but it's probably better than the upper left. In other words, maybe it's something where if I drew a line, my dots might be like this.
Alright.
In other words, that line is a better representation of those dots than this one is.
Yeah.
But not as good as this. Perfect is 1. A correlation coefficient R of 1. Near perfect is 0.9.
Yeah.
Negative,
No.
number 4. In other words, number 3 means that, explain what this means. It means that the more hours you study, the better your grade is. In other words, that's a good correlation coefficient. That's about as good as you can ever expect to get. And what it means is that you have, if you were to approximate a linear regression line, that line would suggest that the more hours you study, the better your grade is.
Yeah.
Okay, that's what it means for number 3. Now, for number 4, it's got a negative correlation coefficient.
Yeah.
What do you suppose that means?
The more you play video games, the worse you're going to do.
You got it. You don't think they'd ever give you one that said the more you play video games, the better you're going to do?
I mean, you never know.
Well, yes, you do. They're never going to tell you that.
Yeah.
In other words, they're trying to deliver a subtle message in addition to statistics here.
Yeah.
They're trying to deliver a message with number 3 that means the more you study, the better you're going to do. And with number 4, the less video games you play, the better you're going to do.
Yeah.
In other words, that curve for number 4 might look like this. I would have dots that would be going like this. And if I draw a line through them, this is your grade, and this is the number of hours you play video games. So as the number of hours gets bigger, your grade gets smaller.
Yeah.
It's almost a perfect correlation. In other words, negative 0.975 is very close to negative 1. Well, if I had a bunch of dots that were absolutely in a line, well, that would have a negative 1 R. It would still mean the same thing. It would mean that the more video games you play, the worse your grade's going to be.
Yeah.
It would just be more predictive. In other words, that if it was a R of 1, it would be absolutely exact. It would mean the more hours you spend, the worse your grade is. This is almost exact, but not quite. Bad correlation coefficients are ones that would look like this. If I have a bunch of dots all over the place, and I try to draw a line through that, I can draw a line through it, but it's not a very good line.
Yeah.
But there aren't very many good lines. I can't draw a line through that. I can draw it that way, I can draw it that way, but none of them are any good. So that's going to have a very low correlation coefficient, maybe an R of 0.1. In other words, the closer it is to 0, the worse the dots go into a straight line.
Yeah.
Okay. Number 5, what does that mean?
I guess we explain it.
Yeah, in other words, that's what they want, is explain what this means. Can you tell me in one sentence is there a correlation between height and test grade? First of all, would you expect there to be a correlation?
No.
No. The test grade you get doesn't have anything to do with your height.
Yeah.
That's why its R is so low.
Yeah.
And that's the explanation, is that your height has nothing to do with your test grade.
Yeah.
That's what you want to write there.
All right.
Or you could say the correlation between your height and your test grade is poor. There's not much. There's no relationship at all between your height and your test grade because that R is so low.
Yeah. Alrighty.
Oh my goodness.
Number 6.
No, yeah, I'm trying to figure out number 6. The only thing, wow. The only thing I can think they want you to do here is add up all of the students. So it's 51, 82, 111, and 62 is 173. There's two classes that both have 31 in them.
Yep.
Unless my math was wrong, that's 26, 51, 78, 107, and 62. My math was wrong. It's 164.
All right.
The only thing I can think that they want you to do is divide each number by 164. In other words, the first high school class would have 2 164ths of the number of total students. And you would make that a decimal. Do you have your calculator in front of you?
I have a calculator for me, yeah.
Do what's 2 divided by 164?
Do what?
What's this number equal to?
2
Uh-huh.
0.012.
And now what's 24 divided by 164?
It's 0.146.
And now what's 25 divided by 164?
0.152.
Get what I'm doing?
Yes.
27 divided by that?
0.164.
And finally, 31 divided by that.
0.189.
Point what?
189.
189?
Yep.
And that's twice. Now, if you add up all of those, you should get 1. And that's central tendency. When you see those words, what it usually means is what percent of the total students does class number 1 have? Well, not much. 1.2%. What percent does class number 2 have? A little better, 14.6%, and so forth and so on. I don't know if that's what they're wanting or not, but I think it might be. I don't know. Central tendency is something that I get about once every 4 years, and I always have to go back and review it because I don't ever remember exactly what it means. And I don't have time to do it in real time. So I'm not positive. This is Algebra 1, isn't it? It's amazing how tough they can make Algebra 1. Hold on. Let me look up central tendency. Pretty sure, wow. Oh, my algebra book is, I don't even have an Algebra 1 book. I have an Algebra 2 book, though. Let's see. This is in statistics. Normal distributions, 746. Let's see if I can figure out their definition of central tendency. Kind of goes, no, it doesn't go with normal distribution. It goes before that. Yeah, hold on. What school do you go to? I'm surprised I haven't gotten it more frequently. Just because I get a lot of Ralston Valley students, but I don't get very many Algebra 1 Ralston Valley students. And I don't know. I don't know if this is part of Common Core. I don't think it is. I don't think this is something you would ever have to know for your SAT test or your ACT test. And the proof of that is that I can't even find it in my Algebra 2 book. The central tendency. Hold on. No, it's nowhere in this book. I'd probably have to go to my pre-calc book to find it. So about the only thing I can suggest is let's skip number 7. I took a guess at number 6. I'm not even sure my answer on number 6 is correct.
Yeah.
But at least it makes some sense. In other words, it would make some sense to know what percentage of total students are in class number 1 and in class number 2 and so forth. So there's at least a logic to doing it the way I did it. But there's something wrong with it because number 7 tells me that it's not the right way to do it. I'm not even sure what they would want for number 7. Best measure of central tendency.
Yeah.
Clearly 84 is the average, 84 is the median, 84 is even the mode. Oh, that's what they mean. They mean, is it the median, the mode, or the mean? I think.
Okay.
And the answer is the mean or the median. Both represent the data in the same way. They both end up being 84, the median and the mean.
Okay.
I think that's what they mean by central tendency. I'm not positive. I'm learning more statistics than I ever knew by doing these sessions with you.
Yeah.
So what's the interquartile range?
4, 8.
4. It's the difference between that number and that number. In other words, the difference between 9 and 5.
Oh, that's 4.
Yep.
Oh no, I was asking if it was question 8.
What's that?
I was asking if it was question 8.
Oh, yes, it is.
Yeah.
So the interquartile range is the beginning of the second quarter to the end of the third quarter,
All right.
with the line in between being the median of all the data.
Yeah.
Okay. So let's look at A.
All right.
Just a second. I need to check that message because I don't know who my next appointment is with. Gosh, what a bummer. I've never had my scheduling program go on the blink before. It's out of action today, so I can't look up my calendar. I can't see who I have after you. I guess I'm just going to have to hope they call me. Or actually, I should be able to go back through my emails and figure out who reserved appointments at a certain time. That's the way I'll do it. Okay, let's see. Let's look back at 8A. What the heck does that mean? Oh, okay. So the question is, what does the 4 mean, and what does the 4 represent in the context of this situation? Oh, I guess it's multiple choice. There's only one of those answers that's correct.
All right.
Is A correct? Does the 4 represent the fact that it doesn't vary by any more than 4 minutes? No, it doesn't, because it looks like somebody had a time of 4 minutes and somebody else had a time of 10 minutes.
Yeah.
Okay, so A is not correct. 1.5, the slowest teams finished in 1.5 minutes. Well, that's clearly not correct. The finishing times were between 4 and 10 minutes. 6, the time it took to complete the obstacle course took no longer than 6 minutes. That's not correct. 4, the middle half of the team's time varied by no more than 4 minutes. Ah, wow. The middle half of the team's time I don't even see how that could be. Oh, yeah, it's okay. That's got to be correct. Notice that from the beginning of the whisker plot to the end is 4 minutes. And the interquartile represents the middle half of the team's times, right? In other words, these are broken up into 4 quarters. There's from 4 to 5 is 1 quarter. From 5 to 9 is the next 2 quarters, and from 9 to 10 is the last quarter. So the middle half of the team's times are the interquartile, and that goes from 5 to 9, which means it varies by no more than 4 minutes. So D is the right answer for 8. D as in David.
Yeah.
All right. This one, it's really clear what they're doing.
Yeah.
What are they doing in the second table? What are they doing to the first table in order to get the second table?
They're finding the percentage.
Yeah, they're dividing the number that's in that cell, 22, by 120, the total number of people. And that gives you 0.183. So what goes in this cell under action?
Yeah. Would that be just 1?
No, it'd be 28 divided by 120.
Oh, I think it's the total.
No, we're just going to fill out every cell in this bottom table.
All right.
Okay? So that's what you need to do first of all, is complete the table.
All right.
And it's pretty easy to do because the top table gives you all the absolute numbers. So every single cell is whatever's in the top cell divided by 120.
Yeah.
And then the totals, in other words, whatever the central frequency of the females in comedy is, add that to the males in comedy to get the total underneath. The totals are always the sums of these two cells.
Yeah.
Same thing with going across. Although you can fill in every cell just by dividing the number by 120.
Yeah.
Okay. So once you've done that, now let's see if we can answer the questions. Well, you know what? I'm going to need to fill it out. Gosh.
I'm almost done, actually.
Okay. What do you have? We have comedy, we have action, and we have other. When you said you're almost done?
Yeah.
Okay, what do you get under males? Males comedy is 0.183. What is females comedy?
0.217.
0.217?
Yeah.
What's males action?
Male action is 0.233.
0.233?
Yeah.
What is females action?
Female action is 0.110.
What's males other?
0.066.
What's female's other?
0.275.
Well, they like the others, don't they? Now, to get the totals, I can just add those numbers.
Yeah.
In other words, I don't need to go back and figure out 48 divided by 120. I know it's going to be the sum of these two numbers, which is 0.4. And the sum of these two numbers is 0.343. And the sum of those two numbers is 0.340. Those three numbers should add to 1.
Yeah.
They don't, but that's because of some round-off error. And then to get the totals here, I just add those 3 decimals across both ways. Now, that should allow us to answer these questions. What is the marginal relative frequency that a person is female in this group? What's the total females if I add these 3 decimals?
Hold on, I got my calculator.
It's 0.5 something, pretty high. Well, I know what it is. It's 0.517.
Alright.
You know how I knew? Because it's the complement of 0.483.
Yeah.
In other words, 0.483 and whatever that number was have to add to 1.
Yeah.
So I took 1 minus 0.483 to come up with 0.517. Now, what's the marginal relative frequency that a person is female? It's 51%. 51.7%.
Yeah.
What's the joint relative frequency that a female prefers comedy? Again, I don't know what they want here. In other words, males like comedy that percentage of the time, females like comedy that percentage of the time. I'm not sure what they're looking for. They're probably looking for this number right here, 217 divided by 0.4. That's probably what they mean by joint relative frequency.
Yeah.
Would make sense, right? It's, in other words, females like comedy a little bit more than males do.
Yeah.
And that number is going to come out to what? What's 0.217 divided by 0.4? 0.5 what?
0.54.
So that's probably the relative frequency that a female prefers comedy. In other words, 54% of females prefer comedy as opposed to 46% of males. Even though this doesn't come out to be 54 and this doesn't come out to be 46, but we're measuring it relative to this 0.4 down here.
Yeah.
You think that's the way it works. What's the probability that someone prefers action given that they are a female? Well, now we're going to compare this number to this number. Divide that number by that number. What do you get?
Which number by which number?
Well, the relative frequency that females like action and the total action, the total people that like action. So I get 0.11 divided by 0.343. What's that give you?
0.32.
So 32% is the probability that if somebody is a female, they prefer action.
Yeah.
You know what? That's not even correct. I think it's 0.110 divided by 0.15 or 0.517. This number over here on the right. In other words, the question states that if you're a female, what's the probability you like action? Well, that's going to be 0.110 divided by this number.
Yeah, it would be 21%.
What is that?
21%.
21?
Yeah.
Okay. Yeah, and that makes sense. Only 21% of females like action comedies.
Yeah.
Or excuse me, like action movies.
Yeah.
About 40% like comedies, and almost more than 50% like other. And you get those by dividing this number by this number here.
All right.
That I'm sure of. Answer to that one.
All right.
All right. God, when are you going to be done with statistics?
Fairly good.
I would hope so. You've been on statistics for 2 solid weeks.
Yeah.
Nobody does statistics for 2 weeks. Not Algebra 1 students. It's unheard of.
Yeah, my teacher.
Are you in an honors Algebra 1 class?
Nope.
You're just in a standard Algebra 1 class?
Yeah.
And they're teaching you this stuff?
Yeah.
Unbelievable. That's going way beyond Common Core. Because none of this stuff is in Common Core. Not a bit of it.
Yeah.
Which means it's not something that you have to know by the time you get to be a senior. It's just something that they're introducing you to a little bit of statistics. Yeah. It's not that statistics isn't important either. I believe it is. I believe statistics and probability are just as important as all the other math disciplines. It's just they're not part of the Common Core. They don't require a student to be proficient in statistics to take college entrance exams.
Yeah.
That's all. So that's why I'm surprised that you're spending so much time on statistics.
Yeah, it is very odd.
All right. I will let you go.
All right, sounds good.
And I will talk to you next Wednesday.